Thanks again for joining, everyone. And Erin, I know you had a late night, so thanks for making the time. This is really exciting for us because it's the first time that we have a speaker who is actively working in the terrestrial robotics for good space. And as folks may have noticed, our name is not We Aerial Drone or We UAV. It's really about robotics, and we're excited about robots that fly, the robots that swim, and robots that drive as well. So we'll have the opportunity now for the first time in our WeRobotics webinar series to really highlight some of the very interesting work that Robot Missions is doing thanks to Erin's leadership. So quick overview of just WeRobotics so that everybody knows what we're up to and gives you information on areas that you might be able to connect with us on. I'll switch to the next slide. Hopefully the video is coming through, but basically our work focuses on flying labs. We use flying labs like Tanzania Flying Labs to localize appropriate robotic solutions and train local teams on how to use robotics for social good. And our teams always engage with local communities directly in the projects that they carry out, which includes humanitarian, environmental projects like the one you're seeing here that focuses on marine life monitoring, conservation, as well as looking at how the impact of climate change is affecting atolls in the Indian Ocean, for example. Another flying lab, we'll switch to the next slide, is our Tanzania flying labs. And they too have been working in the use of aerial robotics for a number of applications, including wildlife monitoring, as well as environmental and agricultural applications. And of course, being a rather disaster-prone country, the team has also worked on disaster risk reduction, disaster response, such as following the massive landslides that you see here. Folks started rebuilding, coming back to where their houses were and building their houses anew. But in many contexts, they were building back in locations that were even more dangerous. And so we were asked by a humanitarian organization to create a high-definition 3D model of the survey, the landslide area, to help do risk analysis for better understanding where families really ought to relocate into safer ground. Next slide, please. And finally, just give you a different flavor for our Peruvian flying labs. They've been working closely with the Ministry of Health in the Peruvian Amazon rainforest to better understand some of the supply chain challenges of delivering medicines and vaccines. You'll note there are no highways or roads really in the Amazon. It's really by riverboat that the main means of transportation is for delivery of medicines. And that can be very time-consuming, expensive, unreliable. And so we've been field testing the use of cargo drones to deliver anti-venom to very remote villages in the Amazon. So for example, this drone is flying to one of those very remote villages. And you can see it here coming in for landing. And the point to note is that it took this drone 35 minutes to reach the village, whereas a boat would have taken up to 6 hours. And so if you've been bitten by a snake in the Amazon, you probably don't want to wait 6 hours. And we also did the first ever night flights delivering blood samples back to a clinic for testing. So that gives you a quick overview of what our current labs are doing. We'll move to the next slide. You've heard now from these 3 flying labs, and if you click again, Peter, we've got 3 additional flying labs coming online next year in 2018. Panama in Central America, Senegal in West Africa, and then the South Pacific flying labs in a region that obviously has been very disaster prone and will continue to be even more disaster prone with the impact of climate change. So it's important work that we're excited to launch in the South Pacific as well. Next slide, please. All our projects focus on the use of robotics in developing countries, and that requires that we are doing this kind of work in a way that is sensitive and directly respectful of local communities, local customs, local norms, and of course, with respect to national and local regulations as well. So we follow this established code of conduct that you can hear and learn more about on our website. Next slide, please. So that's it from me. We're not going to hear from the main star of the show. I'll just say again, what we're excited about is autonomous, remotely operated systems, whether they drive, fly, or swim. And we don't want to just limit ourselves to one type of robotics. If you're all involved or interested in the robotics space and want to apply this technology for social good, feel free to join our roster. If you go to werobotics.org /roster, you'll find out how to join this global network of interested individuals around the globe who apply their skills and time for robotics for good. So with that, Erin, thanks again for making the time. It's really great to have connected with you already on a number of occasions over the past few months and following your work. And thanks for sharing that with us with the WeRobotics global community. And over to you.
Yeah, absolutely. Thanks so much, Patrick. It's super inspiring to see all the work that WeRobotics does, and yeah, I'm excited for ways we can collaborate in the future, because I think that, like you mentioned, robotics is more than just aerial or water-based. It can also be ground-based, though some of the challenges are a bit different. We can accomplish other tasks as well. So super excited to share this with the WeRobotics community, and see if anyone is out there is interested in helping out. So with that, Robot Missions is all about helping our planet with robots. A little bit about me. My name is Erin, nickname is RobotGrrl, and that's because I started building hobby robot projects just for fun. And eventually I started posting these online and built a community around it. My education to learn about how to build these robots mainly came from being self-taught through online tutorials and having communities to bounce ideas off of and ask questions. So the point there being that even if you don't know how to build a robot, it's still possible to learn, and you don't need a fancy degree from a fancy university to do so. Eventually, this led to me creating my first product kit called RobotGrrl, which was an educational robot. Sort of, if you imagine an Angry Bird, but in a robot form, it looked like that. Afterwards, I was able to learn a bit more about digital fabrication through the Fab Academy, which is a class based off of the global network of Fab Labs around the world. So a Fab Lab is a makerspace which has tools such as 3D printers, laser cutters, and access to components so that you can make projects from your imagination into reality. It's a great way to find a community for helping to make that happen. As well, through the Fab Academy, you get connected to all these nodes globally, so that way, whenever there's a gathering each year at, say, the FabX conference, you get to meet everyone and share your project there. Eventually, that led to me getting a fellowship in social innovation, which was really where I learned about applying tech skills for social good. And that's how Robot Missions got launched out of it. So Robot Missions is empowering communities to embark on missions facing our environment using robots. This picture that you see here was one of our field tests, where basically we bring robots out into the public onto the beach and have participants and volunteers help operate them. And we'll talk more about that in a bit. The reason why Robot Missions was launched was because we saw the effects of the global pollution challenge happening here in a local setting. The first instance of seeing this was actually when I was on beach on Lake Ontario, which is located in Canada. And basically there was this pile of debris at my feet, except that it was all this tiny trash debris, items like fragments of plastic, styrofoam, and cigarette butts. All these really tiny pieces that go unnoticed by manual efforts and larger machinery can't pick up. But the thing is that all this debris leads to accumulation. So if we aren't picking it up now, it's going to end up still being on the beaches. So in this photo, what you would see is typically you would go for the cup, the blue cup that would need to be picked up. But there's also in the center of the frame all the tiny things. And here you can see a better view of it. What's crazy about this image is that there's this big city in Ontario called Toronto, and it has an interesting skyline. So people really like to take photos of this. So they come onto this area of the beach and they take a photo of what they see behind them, but they don't bother to look down at the ground and what they're standing on. And this area of the beach is littered with all of this tiny trash. Here you can see a few circles in amongst the pieces of bark and wood. Those little circles are actually called plastic nurdles, and they are the raw material that goes into making plastic products. So what this indicates is that it is more than just our human behavior that is causing this pollution. It's also a combination of sewage overflows and possibly some industrial dumping that is occurring. So what we want to see in the world and in this location is obviously cleaner beaches. But the vision is much grander than that. We want to be able to see one robot per park in Ontario by 2030, and of course expand globally. The reason why is because we want to increase the efficiency for collecting this tiny trash debris. Simply put, our manual efforts won't be able to be sustainable in tackling this challenge, especially as the rate of plastics entering our waterways is expected to increase in the future. So in saying that, I realized that one robot per park is a sort of really big vision, and right now we're at the stage where we're just at the base of this mountain looking up at the peak and wondering how on earth we're going to get to the top. And with this mindset of just making things, the best way to do this is to just start. We can't just wait for a solution to be magically invented, but through citizen science and through the power of the maker movement, we can start working on solutions and inventions to these problems ourselves. So here, obviously in the photo, you see Bowie, which is the nickname of our robot, climbing up the peak of this mountain to illustrate that point. And to get there, it's going to take a really long time and a lot of iteration. So this, for example, was one of our very first prototypes of the robot. And with the prototypes, it really served as a way to communicate what our idea will eventually become. There was a lot of mistakes and breaking of the robot along the way. Instead of testing the robot in a laboratory setting, which typically would have happened for fancy laboratories and universities that are really big research projects that would typically tackle such a big challenge, Instead, what we did was we just used the real world environment as our testing grounds. And with that, we were able to learn a lot more about things that have to be fixed on the robot. And of course, we wanted to be able to test the robot in different contexts as well, not just on shorelines. So we brought the robot out to Frozen Bay and tested it how it would work on ice. It turned out the robot worked pretty well, though in this instance the robot lost a wheel. But thankfully, if we wouldn't have done that, we wouldn't have realized that there would have been a potential design improvement we could have made to the wheels to prevent that from happening. Now, since then, we haven't had a wheel fall off, and the robot's been through mud and much more than just ice. What came after this robot was the current iteration that we're on now. And then once we had that, and we've started testing it this past summer, then we've had people start replicating it. Because the robot is 3D printed, it means that using distributed manufacturing, this can reach places in the world way faster than if it was being produced in one central location. So we have this photo of our white and gray robot sort of giving a green robot a robotic high five with their scoop. The green robot was replicated across Lake Ontario in Rochester, New York, in USA. So that means that there are at least 2 robots on separate sides of the lake. So eventually we hope to cover the entire perimeter with these robots. And it just goes to show that through this sort of iteration process of developing a prototype, eventually it leads to where other people see this and they want to replicate it too. If you design for being able to replicate through distributed manufacturing, say for example 3D printing, this reduces the time so it's way faster to get this to other places in the world. Okay, so we mentioned at the beginning about field tests where participants join in and test out the robot. What's magical about field tests is that it brings together volunteers across the technology, environmental, and educational communities. This means that we get a really cool mixture of people that are interested in learning more about the robot and adding their experiences into the mix. Meaning it's not just one specific type of person that's interested in this. Everyone brings their own sort of muse as to why they want to be there and why they want to participate. So there's 3 really fun moments that I would like to share with you about field tests. This here was one of our field tests from a few years ago where these 2 girls, they were running late to a birthday party, but they saw this robot and they wanted to stay and learn about how it works and how to use the robot. The best part is that the robot controls, we make it as simple as possible. So when people are sort of scared or timid about using the robot, what we say first is, it's just like using a Nintendo. And Nintendo here is a popular gaming system with really simple controls, like a few buttons and a joystick. And so that reduces the barrier for them just being comfortable with testing the robot and trying it. Another thing that's great here is that this is showing the future of environmental stewardship. Eventually, these students will become older and have this in mind when they start learning about STEM, and maybe they'll even build one of their own robots to do some environmentally themed missions as well. Next up is this photo. This was from our latest field test in Ottawa. And what's interesting about this is you can see different generations in this photo, and also two people in the back who have just come out from swimming in the water to check on the robot and hear more about it. So it paints this picture of this coexistence between humanity and robots working at the same time. So, you know, in the future, it'll be totally normal for people to be enjoying nature and having robots working alongside us to help preserve these natural spaces. And in this photo, you can see two members of a Girl Guides unit. Girl Guides is a sort of a community club here in Canada and probably USA where younger girls get to be mentored and do sort of outdoorsy themed activities. Basically, it provides them a way to become really good citizens in the world. We were able to do an activity with a local Girl Guides unit, and they controlled the robot to go through this path deep into the woods. And one of the girls said, like, she isn't interested in STEM, but she loves learning new things. And so this robot was a way for her to learn even more about the environment and technology. So even if you aren't interested in the like in the sciencey or engineering side, there's still so much to learn about how we can protect our environment, clean it up, and the role that citizen science plays in doing this in the future. All of these observations through field tests when we were basically testing out this robot to see how more efficiently it can pick up trash, it led to seeing that education is also a path that this robot can take. So what we did was we decided to use the tech that we have now and create a program called Adopt-A-Bot, where we run educational workshops in schools and also let classrooms adopt a robot for a month into their class. This actually provides them with a robotics experience that is less of a price than it would be for the school to invest in an entire robotics kit for their class. And plus, the huge benefit here is that it takes the current knowledge of the students and applies it to a real-world problem. So we're still working on rolling this out to schools. We are currently working on fulfilling Adopt-A-Bots for 3 schools, and as well as doing more workshops. So far, we've worked with SHAD and Girl Guides on this. Now, of course, the whole key to this is that Robot Missions is putting the tools of helping our environment directly in the hands of the community. So no longer would you need to, say, work for the park in order to have fancy tools to do this. Eventually, it will be possible for everyone to be able to do this themselves as well, and to start these community initiatives to be able to tackle all of these challenges together. What we're really looking at here is that this type of robotics will be democratized so that everyone can do this. So whenever Patrick emails, it's kind of cool because he always puts onwards at the very last portion of his email. And it makes me think about how we're always saying about how we're going to harness the power of robots, except that when we say we need to harness the power of robots, what we're really saying is that we need to harness the power of humanity, as we design and build this audacious technology to help our planet. And with that, there's a few ways you too can become a robot missions hero. So we're going to be looking at people starting a robot missions chapter at your own location. Perhaps that could be a bit similar to the Flying Labs initiative. As well, we're looking for connections to decision makers in cities, such as mayors, councillors, environment and innovation ministers. This way, we'll be able to convince them that doing a trial of our robots is important, so that way they can then communicate that message to the people working in the parks. We found that this is most likely going to be a better strategy than, say, going bottom up, just because of the risk factor involved. Usually people working directly in the parks are unsure about taking on an innovative project, so going top down will hopefully lessen that impact and make it more like an adventure, like let's try this out. We're also really looking for sponsors, so please, if you know of anyone who can help keep this going, that would be amazing. We also have a Patreon page and a donor box link on our website if you feel so compelled through this presentation to help out. There are other ways to help out as well. So for example, if you have a 3D printer, feel free to reach out and you can contribute some of your 3D printer time and filament to a crowdsourced replication of our robot. We've actually started doing this with some printers here in Eastern Ontario, and we're almost finished the first crowdsourced replication, but it will be cool to also open this up to other places in the world as well. Though in saying that, I have this image of being surrounded by robot parts in my lab, and yeah, so we'll see how to expand this slowly so that way we're not swimming in robot pieces. And finally, you can help spread the word and follow us on social media. It always helps for people to retweet and share our messages with their own friends, so that way it expands our circle of influence, so that way we can get more people on board with this, with the end goal of being able to help our environment with robots. The reason why we're doing this is because we believe we all have the duty to preserve our natural spaces, and along with the nation completing missions together, our robots will help accomplish this. So thank you, WeRobotics community, for tuning into this, and happy to answer any questions.
Thanks so much, Erin. This is exactly what I was hoping for with your presentation, and just reinforces how much we have in common in terms of how we look at the world and our role in it. I really liked how you said about the distinction between sort of harnessing robotics versus humanity. You're absolutely right. I just couldn't agree with you more, and your focus on specifically empowering young girls around this technology and building their skill sets is really so important, and is something that we're hoping to do more with our flying labs, in particular starting with our new flying labs in the South Pacific. With a little luck, the coordinator of that flying labs will be our first female coordinator, which is way overdue, and hopefully then, you know, she will be in a position to serve as a role model and engage others. And I'm thinking about the South Pacific as well, because that could also be a really interesting application. I know that our colleagues there have been working on a number of environmental projects, so I'll be sure when I actually speak to them later today to also flag your project, and I'll be sure to send them the recording of the webinar as well when it's available. And just And so I guess one other point for everyone else will be who is and will be listening. Erin and I have been exploring the application of this technology at potentially our flying labs in Nepal earlier on when we started discussing. And so, for us, we obviously this is really exciting for us, and it would be a great opportunity to really start introducing a robot that doesn't fly, and would really, I think, help build the skill sets of our local teams as well. So I guess I can start with the first question, and then let's open it up to the rest. If there are other questions, what's the latest in terms of when do you think one or more of our flying labs might be able to partner with you to actually do an initial demo or initial project overseas?
That's a good question. So currently, what the timeline looks like is we're pretty close to being able to release the robot as open source hardware. What's preventing us from doing that is just resources in terms of personnel and time. The electronics are nearly complete. So we have a circuit board made for both the controller and the robot's brain. Next up would be completing the documentation for the robot to make sure people there can utilize it, build on it, and remix it for their own purposes. So to put that in terms of like actual months,
it's hard to say some time. I completely understand. It's a tricky question.
Right now, I can tell you in my lab we have one complete robot and 2 robots that are in pieces and half a robot that has pieces. So it's just taking some time to get them all printed, assembled with all the right components, and then shipping them out. So we have a list of about 4 robots that we still have to complete. And then after that, we can start seeing who else to add onto the list. Of course, there is also some capital required for making the robots. So, yeah, that's another problem that can be tackled eventually. So basically what I'm saying is hopefully by the time summer rolls around, that would be really cool to be able to send a robot to Nepal.
Very cool. Or the South Pacific, or both. Yeah, I think as next summer gets closer, it may be worth putting together a proposal and shopping it around whenever you're ready. And it's important to get the tech right as well. I get that, and learn by doing as you're doing. In Canada, I really liked what you said about that. The lab is the real world, and I really love the idea as well of this idea of leveraging sort of distributed network of people with 3D printers. I just think that's a fantastic idea. There's a lot of that. There's analogs to that, or equivalents to that with software, right? Where you lend your laptop for data processing for some projects, and this is the kind of the hardware component, which is fantastic. So I've taken up too much time being very selfish with questions. If there are any other questions, though, I'd love to take them now and discuss with Erin from anyone else on the call.
What was fun also about that green robot was we assembled it a few hours just prior to the field test. And also the quality was so much better than the one I made myself. So it's like, well, great.
You iterate, that's good.
Yeah.
Very cool. So I imagine there are no other questions right now. But what we'll do is we'll invite folks who are viewing this webinar. We have something from Alana. How technologically savvy do you have to be to put this together, Erin?
I think,
is this something kids can do with supervision?
yes. I think so to answer Elena's question, I think being patient will be more important than being tech savvy. Depending on how well we do the documentation, which will depend on how much resources we have, the main thing will just be putting the pieces together in the right way. For the electronics, it will typically be just plugging in wires. And the microcontroller is based off of the Arduino environment. So if you're familiar with programming Arduinos, that will be a great starting base knowledge for learning how to modify the program of the robot.
Yeah, it's learning by doing it. Your point about patience also, that applies for, I think, all all robotics, the flying kind as well. I feel like it does take patience and to keep learning and troubleshoot and so on, even with the commercial products that are available. Great. Well, and Amadou is saying that he hopes to see some of these in Dakar soon, which
Nice.
could also be very much an option with the work that we're going to be starting to set up there through our flying labs next year. So we'll keep that in mind, Amadou. Thank you. All right, I think we're good. But Erin, let me post. Well, if anybody has follow-up questions, obviously, please follow up with Erin. And you're, of course, feel free to get in touch with us at any time. If you have ideas and other suggestions for topics and speakers, issues you would like to see discussed in a future webinar, then by all means feel free to get in touch. This is really for the community to get to learn and exchange ideas and to collaborate. So with that, thanks so much, Erin, for being our first ever speaker and collaborator on terrestrial robotics, and we're hoping that maybe by this time next year you'll be back, if not sooner, giving a webinar presentation on a joint project that we'll be doing with our flying labs and robot missions.
That will be amazing. Thanks so much, Patrick, and the WeRobotics community for tuning in. This is great.
Super. Well, thanks, everyone, and we look forward to having you join a future webinar, which will likely be on cargo drones in the Amazon in coming weeks, so stay tuned for that. And thanks again, Amadou. Thanks to Lana and Erin, Peter for also organizing, and have a great rest of the week, everyone.
Bye.
Bye, everyone. Bye.